So I'm showing you a friendly neighborhood calculator can help us out with this because some of us don't know this off the top of our heads, right? Okay, so I'm going to open a calculator page. I'm going to press Control and then the up arrow. Control and up arrow. Can you see what that says right there? N root x. So if I press that, Control up arrow, what I get looks like this. And I can put in the fifth root of 16,807 and just press enter. I could press in Control up arrow. I could press in fourth root of 81 and get 3. Yes? If you didn't know that you could take other roots besides square roots in your calculator, now you know, yes? Okay. Now, we have to be careful because if it says the fourth or even the square root, let's just do square roots. Square root of 7. Do you know the square root of 7? Well, I don't either. And when I press it in my calculator, it's a decimal. If I have the square root of 7, I want to leave it as the square root of 7. I do not want the decimal. I want the exact answer, and this is a rounded answer. The exact answer is just the square root of 7. Does that make sense? Okay. Now, sometimes the problems might look like this. Sometimes the problems might look like this. Okay. And sometimes you freak out when you say fractions, so please don't freak out when you see the fractions. Please realize that if I have the square root of a fraction, all I'm doing is taking the square root of the numerator and the square root of the denominator. What is the square root of 4? And what is the square root of 3? I mean 9. I told you the answer, sorry. So the square root of 4/9 is just 2/3. You okay with that? What's the cube root of 27 over 125? Well, what's the cube root of 27? 3, right? Because 3 times 3 is 9 times 3 is 27, so the cube root of 27 is 3. What's the cube root of 125? 5. Okay with that? What about the fourth root of 1296 over 6561? You don't know that off the top of your head? Yeah, I didn't either. I had to use a calculator, right? Now here's what happened. When I first did this problem, I did the fourth root of 1296. Whoa, not that. The fourth root of 1296, and I got 6. And then I did the fourth root of 6560. Oh, geez Louise. 6561 and got 9. 6 over 9, right? Is that the answer? Oh, it's definitely not the answer, right? Because they're both divisible by 3, so it's 2/3, right? But then an earlier class period helped me realize that if I just did the fourth root of 1296 over 6561, it would tell me the answer is 2/3. Yeah, I was just trying to do it little pieces and parts at a time, but it helps me out, right? Calculators can help us out when we know how to use them, yes? Okay. We definitely don't want to just rely on them all the time. We want to be able to use our brain, right? So these are all fine and good when we know square roots of stuff, right? But what if it's a number I don't know the square root of? Like the square root of 20. Do you know the square root of 20? No, neither do I. Okay? So I can't just leave it as the square root of 20 because that is not simplified all the way. Knowing the properties of square roots, what I can say is this is 4 times 5. The properties of square roots also say I can separate this as the square root of 4 times the square root of 5. Guys, do you know the square root of 4? 2. Do you know the square root of 5? Neither do I. This is simplified instead of this. I don't know the square root of 20, but I know a number that divides into 20 that I do know the square root of, right? Guys, instead of 4 and 5, why didn't I choose 2 and 10? Do you know the square root of 2? You do? Oh, you don't? Do you know the square root of 10? No, I don't want to choose 2 and 10 then. I want to choose 4 and 5 because I know the square root of 4. Does that make sense? What if it was the square root of 125? Do you know the square root of 125? We know the cube root of 125, right? But what about the square root of 125? We don't know that, do we? But we know the square root of 125 is what? 5 and 25, right? Which is the same as the square root of 25 times the square root of 5, which is the same as 5 root 5, because I know the square root of 25, so I can take it. Why didn't I choose 75 and 3? Well, first of all, it's not 75 and 3, right? 75 and 2. Sorry about that. No, it's not even 75 and 2. I don't even know what's happening anymore. Do you ever feel like that? Yeah? Okay, sorry. But why wouldn't I choose numbers like that? Because I don't know the square root of those numbers, right? Okay. Any questions? So you know at some point I had to throw some variables in here, right? So let's start here. What's the square root of x squared? X. What is the square root of x to the 6th? What times itself equals x to the 6th? We have to remember exponent rules here, don't we? Isn't this the same as x to the 3rd times x to the 3rd? When we're multiplying like bases, don't we add our exponents? So what is the square root of x to the 6th? X to the 3rd. Does that make sense? So then what about x to the 9th? I already told you that the square root of x to the 6th is x to the 3rd, because that's usually what people tell me the square root of x to the 9th is. They say it's x to the 3rd, right? But that's forgetting the fact that when we multiply like bases, we add our exponents, not multiply them, right? Okay, so how can we break this down? We could break it down into 5 and 4, but there's a bigger one that we know the square root of. How about 8 and 1? Don't we know the square root of x to the 8th? What is the square root of x to the 8th? X to the 4th. Because x to the 4th times x to the 4th is x to the 8th, right? X to the 4th times x to the 4th, isn't that x to the 8th? Because when we multiply like bases, aren't we adding our exponents? So the square root of x to the 8th is x to the 4th. What's the square root of x? I don't know either, so I leave it. Okay? So what about the square root of x, y squared? Do I know the square root of x? No, I had to leave it inside. Do I know the square root of x squared? Yeah, it's just y. So my answer is y square roots of x. What about the square root of x to the 5th, y to the 4th? Do I know the square root of x to the 5th? No, but I know it's x to the 4th times x, don't I? And what's the square root of x to the 4th? So x squared, right? Do I know the square root of y to the 4th? Y squared, but what do I have left over? That x. Now, what I've heard today so far is, Ms. Kingston, this doesn't look simplified. This one looks simpler. I agree with you, right? But those are two different words, aren't they? Something being simple and simple being simplified. Those are two different things. This one does look simpler, but it's definitely not simplified. This one doesn't look as simple as this one, but it is simplified. Does that make sense? 45, x to the 9th, y to the 8th, z to the 7th. Do we know the square root of 45? We don't, do we? But what do we know about 45? 9 times 5. Why did I choose 9 and 5 and not 15 and 3? I know the square root of 9, right? I know the square root of 9. What is the square root of 9? 3. And I have to leave the square root of 5 inside, don't I? Because I don't know it. Do I know the square root of x to the 9th? No, but thinking back about here, I know it's x to the 8th times x, and I know the square root of x to the 8th is what? X to the 4th, and I still have this other x that I have to leave inside, don't I? Do I know the square root of y to the 8th? What is it? Y to the 4th. And do I know the square root of z to the 7th? No, but I know it's z to the 6th times z. And what's the square root of z to the 6th? Z to the 3rd. And then I have the one more z left inside. Got it? Sure? Okay, that's a little terrifying, but that's okay. We can use it. Okay? You also need to be able to do some operations for me. I'm not talking about like appendix operations, just for the record. Okay? 3 square roots of 5 plus 6 square roots of 5. What is 3 square roots of 5 plus 6 square roots of 5? Be brave. Make a guess. 12? Okay, where'd you get 12? You just guessed. Okay, that's fine. So how about if we make an educated guess? Use the numbers that we're given. We have a 6 and we have a 3. That's 9 square roots of 5. 3 square roots of 7 plus 12 square roots of 7. 15 square roots of 7. What about 2 square roots of 3 minus 3 square roots of 3? This is minus. Negative 1 square roots of 3, or just negative square roots of 3, right? What about 9 square roots of 5 minus 2 square roots of 5? 7 square roots of 5. Guys, is the square root of 5 a variable? It's not, right? It's a number that I'm taking the square root of. There's an exact number, or there's an exact answer for that, right? But when we're adding or subtracting, does it act like a variable? Yeah, it stays itself, right? Well, the other way that it acts like a variable is, what if we have this? 3 square roots of 2 plus 4 square roots of 50. Can I add these two? When can I add radicals? When they are the same, okay? But is this a radical I can simplify? Do I know a number that divides into 50 that I know the square root of? Isn't that 25 and 2? What's the square root of 25? 5, right? When I pull that 5 out, I have a 5 times the 4. What is 5 times 4? 20 square roots of 2. Is this a problem I can do now? What is it? 23 square roots of 2. So it's not, the radical is not a variable, but it acts like a variable in that when I add them, the radical stays exactly what it was before, right? And I can't add radicals that are not like, but for radicals anyways, I can simplify them to make them the same, and then I can add them, right? What about 12 square roots of 5 minus 4 square roots of 20? What are we going to choose for 20? And? So 4 times 5. What is the square root of 4? So I have 2 times this 4 that's already there, so 8. What is 12 root 5 minus 8 root 5? Yeah, 4 square roots of 5. How do you feel about adding and subtracting? Whether the radicals are the same or whether they're different. You okay with that? Oh yeah, me too. I like the same ones better, right? Because they're a little easier, right? So if we've done adding and subtracting, what do you think we're going to do next? Yeah, that's our next operation, isn't it? So let's start with this. The square root of 2x times the square root of 2x squared. Well, can I multiply these? Think about it, right? When I took this 20 right here and separated it into two parts and then separated them into two parts and I could do that, am I allowed to go backwards? I sure am, aren't I? So I have the square root of 2x times the square root of 2x. That should equal the square root of 2 times 2, 4, x times x squared. Yeah, absolutely. Is that as simplified as it could be? Do I know the square root of 4? Yeah, it's 2, isn't it? Do I know the square root of x to the third? No, but I know it's x squared times x. And do I know the square root of x squared? It's x, right? But I still have this square root of x that's still inside. What about the square root of 10 x to the third y times the square root of 4 xy to the fourth? What do I get here? This only works because we're multiplying, right? Wouldn't work at all if I was adding, would it? Okay, so what's 4 times 10? 40. And what's x cubed times x? X to the fourth. And what's x times y to the fourth? Sorry, y times y to the fourth. Y to the fifth. Good. Is that as simplified as possible? No, why not? 40 is what? 4 times 10? And I know the square root of 4, right? Is there any other number that divides evenly into 40 that's like bigger than 4 that I know the square root of? Like 9 or 16 or 25 or 36? There's not anything bigger than 4, is there? Okay, so I know the square root of 4 is what? 2, and I still have the square root of 10 inside. Well, sorry, still have the square root of 10 inside that I can't do anything with, right? What about x to the fourth? Do I know the square root of x to the fourth? X squared. Do I know the square root of y to the fifth? No, but I know it's y to the fourth times y, don't I? And what's y to the fourth? What's the square root of y to the fourth? Y to the second, and then I still have this y that's inside. How do you feel about multiplication? Okay-ish? Okay-ish enough for me to go on to division? Okay. Can I warn you before I even finish writing this problem? What are division problems going to look like? They're going to look like fractions, which automatically to you guys make them ugly and scary, right? Please take a breath. 4b to the 10th, c to the 5th, over 45. We're not going to panic, okay? I'm going to start off with a division bar. We're going to take it one term at a time. What is the square root of 4? What is the square root of b to the 10th? B to the 5th, right? B to the 5th times b to the 5th is b to the 10th, right? So that's how I take the square root of it. What about c to the 5th? Do I know the square root of that? But it's c to the 4th times c, and what's the square root of c to the 4th? C squared. So do I have anything left inside my radical? A c, right? Okay. What's the square root of 45? Yeah, I don't know either, right? But what do I know about it? 9 times 5. What's the square root of 9? 3. And then I still have a square root of 5. Now, that would be really nice if this was the answer. I'm not kidding. You know I don't kid about stuff like this, okay? Now, have we done everything right so far? Yes, we have. 100% we've done everything right so far. But here's the deal, guys. We cannot leave a radical in the denominator of a fraction. Okay? But again, we don't panic here. Okay? Here's how we're going to get rid of the denominator, the radical in the denominator. Whatever the radical that's down there, it's a square root, right? So this is how we do it. Whatever the radical that's down there, I multiply top and bottom by that number. So I'm going to multiply the top by the square root of 5 and the bottom by the square root of 5. And the reason I'm going to do that is, what is the square root of 5 over the square root of 5? Anything over itself is just 1, right? So if multiplying by 1, I'm not changing the value of the equation. But multiplying by the square root of 5, in the numerator, I get 2b to the 5th c squared root of 5c over 3 times the square root of 5 times the square root of 5. What is the square root of 5 times the square root of 5? Square root of 25. What is the square root of 25? 5. What is 5 times 3? 15. Do I have a radical in the denominator anymore? Then that's as simplified as I can get it. Okay, let me teach you a quick trick right here. What's the square root of 5 times the square root of 5? 5. What's the square root of 12 times the square root of 12? 12. Now we could go like the long way. We could say square root of 12 times the square root of 12 is the square root of 144, and the square root of 144 is 12. Or we could see quickly the pattern. The square root of 5 times the square root of 5 is going to equal 5. The square root of 7 times the square root of 7 is going to equal 7. Does that make sense? Okay. One more. The square root of 9s squared over 25r to the third. The square root of 9s squared over 25r to the third. Give myself a division bar. What is the square root of 9? 3. What is the square root of s squared? What is the square root of 25? What is the square root of r cubed? We don't know, but we know r squared times r. And what's the square root of r squared? R, but I still have a radical r underneath. So what am I going to multiply this fraction by? Square root of r over the square root of r. So in the numerator, I have 3s square roots of r, and in the denominator, I have 5r, but then I have the square root of r times the square root of r. What is the square root of r times the square root of r? R times r, and then 5, right? So 5r squared. How are you feeling about this? Nervous? That's fine. That's fine. Okay? What am I going to tell you to do when you're nervous? Breathe. Don't panic. Relax. I want you to take it little steps at a time, right? We didn't try to do this problem all at one time. I said, what's the square root of 9? Then, what's the square root of s squared? Then, what's the square root of 25? Then, you see what I'm saying? Take it little pieces and parts at a time, and you'll be better. Okay? Peace.